Since the early 2000s, two main displays have dominated the commercial markets, LCDs and plasma. More than a decade later, these remain the most popular displays used. Despite their maturity and popularity, they are not the best display technologies available. Organic light-emitting diodes, or OLED technology, presents a promising replacement for LCD and plasma displays.
The main disadvantages of LCD displays. They suffer from motion blur, poor contrast ratio, bad viewing angles, and also slow response time. The main disadvantages of plasma displays. They are heavy and fragile, produces excessive heat, uses more energy than LCDs, and also has a shorter lifespan than LCDs. OLEDs can overcome these issues. Pros of OLED displays. It improves contrast ratio, creating true blacks. It's also thinner, lighter, and also more energy efficient. It's brighter and easier to produce, and it's also more durable. They have the potential of being cheaper to mass produce. In future displays, it could have a greater lifespan. This can also reduce glare from natural light and can be very readable in sunlight. They provide a wider viewing angle and also reduces the power consumption, providing a superior battery life.
What is OLED technology and how does it work? OLED is a new emerging display technology. They differ from LCDs mainly in the sense that they don't use a backlight. In OLEDs, the pixels produce their own light when current is passed through it. The lack of this backlight is the reason why OLEDs can be made thinner and lighter. OLEDs function using a method called electrophosphorescence. Electrophosphorescence is a method of creating light without producing heat using an electric charge. Different layers in the OLED structure include the substrate, which is the backbone on where the display rests. This is usually made of glass but can be made of plastic or even metal. There are two electrodes in the form of a cathode and an anode. Lastly, there are two layers of organic molecules or polymers. The process of creating light begins when electric current flows from the anode to the cathode. This causes some electrons to become displaced in the organic layers. These electrons in the organic layers react, causing a flash of light and ultimately creating a picture.
Types of OLED displays. Transparent OLED displays use transparent substrate. This is effective in situations where people cannot look away from a display due to safety reasons. This display can be used in augmented reality hardware, smart windows, and heads-up displays, like while driving in a car or driving an airplane. White OLEDs. As the name suggests, these types of OLEDs produce just white light. The purpose of this is to one day replace current fluorescent lights with more energy-efficient light panels. Flexible OLEDs. Using plastic or flexible metal substrates. Flexible OLEDs are more durable and shatterproof. They're also used in smartphones, smartwatches, TVs, amongst other electronic devices.
The main applications of OLEDs is the improvement of mobile devices as well as television and computer displays. With mobile devices, the reduced power consumption by removing the backlight provides improved battery life. By removing the backlight and using plastic substrates, the devices are able to become much thinner and lighter. OLEDs are also much brighter and more readable when being used outdoors, and the ability to flex and bend the screens allows them to be more durable and resistant to damage, and allows more control over the device. For television and computer displays, the reduced power consumption makes the screens less expensive to run. The higher resolution and contrast ratios provided give much better pictures, and because the colors do not change at an angle, OLEDs provide better overall viewing experiences. The ability to curve a screen also can give a surround experience similar to that used in IMAX theaters, without increasing the physical size of the display. OLEDs can also be used in lighting panels and advertising signs. OLEDs are able to be used to create interactive heads-up displays in cars, airplanes, smart windows, and augmented reality systems. Future concepts for OLEDs include weaving displays into clothing and personal accessories as a means of personal expression or advertisement.
As technology is improved and developed, OLEDs are quickly becoming the best available display technology for a wide range of devices, products, and uses. What was once thought to be impossible will soon become an integral part of everyday life thanks to this new emerging technology.